everybody. We are going to talk about some properties of integration today. Full disclosure, Gemma is currently watching Daniel Tiger and may or may not run in here at any minute. So we'll deal with that if it happens. All right, so we're talking about properties of integration. So even if we don't know the function that we're integrating, it is sometimes possible to use properties of integrals to figure out the integral. So property one, we have this full integral right here. And notice that these two are the same function as this one, just kind of on a smaller scale. And so if we know this first part from 0 to 2, and we also know from 2 to 3, we can figure out the full integral from 2 to 3 by adding them. Okay, so the two different integrals added together should give us our third integral. And this doesn't have to be with these specific numbers. You could have like A to B, and then if you had A to C, and then from C to B, then you could add those two together. So the full property for this is that the integral from a to b of f of x dx is going to be equal to the integral from a to c of f of x dx plus the integral from c to b of f of x dx. Okay, so that's our full property. The key thing here is that we included this c and we split it into the integral into two pieces. Okay, so that's the first property, the sum of integrals. Then the second property, so here we have the same function, but this one is just stretched out vertically. It has a scale factor in front of it. Okay, so for this one, that scale factor right now is just like stuck inside of the integral. But this is saying that I can take my scale factor and I can just multiply this integral by whatever that scale factor is to get the same summation. Okay. So now property 3 is going to be, property 3 is going to be another form of summation. So here we have the integral of the sum of f of x and g of x. Okay, you can see where we stacked this first one or this second one on top of this first one, and that's going to be equal to the same thing as just adding them separately. Okay, so those are those three properties. I'm going to stop the video right there, and then I will come back and do the practice at the bottom in a minute. We're back. It's been a minute for me. You guys are like watching this in a row, so it doesn't seem like a minute. But my child is supposed to be napping, and this is her. Just, fooling around. Oops. Not doing anything. So if you hear in the background, that's what's going on. Okay, so here we go. So we're doing the examples on this sheet. It says given that the integral from 1 to 3 of f of x is 7 and the integral from 1 to 3 of g of x is 3, evaluate the integral below. So we know from our property 3 that we can just rewrite this as the sum of those two integrals from before. Oops. All right. And we know what each of those are. We can replace them with 7 and 3. So we should get 10. Okay, so we use the pieces that we knew and the property that we were given to get our final answer. And number 2, it gives us that, the integral from 1 to 2 of f of x is 1.5. And it wants us to evaluate the integral below. So it's 100 times f of x. So we can rewrite this like from property 2 and put our 100 in the front. Put f of x just on the inside. Now, notice that just this section right here is the exact same as this, which we know is equal to that. So we can replace the integral with just 1.5. Okay, and when we multiply those, we should get 150, and that should be our final answer. Okay, so those are those two examples in the front. Let's flip it over. So I think if we were in the class, I would ask you to do excuse me. I would ask you to do number 3 and 4 on your own. Then we go over them together. So go ahead and pause the video, and then you can like play it, watch 3, pause, and then do 4, and then watch 4. So it says given, we have the integral from -10 to 5, and then the integral of the same function from 5 to 10. So it wants us to evaluate this. Conveniently, going from -10 to 5 and then from 5 to 10 covers this entire interval right here. So we can just add those together. -10, 5, f of x dx, 5 and 10, f of x dx. And then this is just going to be equal to 14 plus 18, which is 32. Sweet. All right. Now we'll do, you can pause if you want. And I'm going to draw this out just so that you guys, just to reiterate. So maybe f of x looks like this. It doesn't have to, but maybe -10 is here, +10 is here, and 5 is there. So what it's saying is that from -10 to 5, this area is 14. This is supposed to be a 14. And then from 5 to 10 is 18. And so we're just combining those two pieces together. So it's like adding horizontally, all right? And that is property 1, okay? And then for number 4, we have the integral from 0 to 3 for both of these things, and it wants us to evaluate the integral. So this is combining a couple different properties. So we have the sum of the functions, okay? And then we also have these scalar multiples. So we can split the integral up and we can pull the scalar multiples out front. So I'm going to put my scalar multiple out front, put my function in, split, put my other scalar multiple out front, and then we can substitute. We know this integral right here is 1, so we can put a 1 right there instead of the integral. We know that this integral right here is 4, so we can add 6 and then replace that integral with a 4, and so we get 10 plus 24, which is 34. Okay, and that should be your final answer. Hopefully that made sense to you. If you disagree or have any questions or comments, please comment in the discussion board and I will try to remediate those questions for next class. All right, so it says the chart below shows the values of f of x and g of x and their derivatives at various x values. Use the information, this is supposed to say given, oops, in the chart to answer the questions. Okay, so the important things here, so we'll start with number 1. It wants us to integrate f prime of x from 0 to 2. So some things that are going to be helpful are like f of 0 and f of 2, okay? Because when we integrate f prime, we should just get f. And then we want to evaluate from 0 to 2. So this means that I'm going to want f of 2 and I'm going to subtract f of 0 from it, okay? Those happen to be 6 is f of 0 and 8 is f of 2. So when we subtract, we should get 2. Okay? So hopefully that makes a little bit more sense about how this table is working. So let's do number 2. It says the function h of x is given by h of x equals 3 times f of x minus g of x. So first it says evaluate h of x at 1 and 3. So h of 1 is going to be equal to 3 times f of 1 minus g of 1. Okay. And we know what f of 1 is. Whoops. F of 1 is 7. And g of 1 is 6. So I'm going to have minus 6, which was g of 1. So this is 21 minus 6 should give me 15. Okay. Then we'll have h of 3. So we have 3 times f of 3 minus g of 3. Oh my gosh, this child is like bouncing on her bed. Also, she's supposed to sleep from 12 to 2 and it is 1:30 and she's not slept. So f of 3 is defined at 9. So I'm gonna have 3 times 9. And then g of 3 is 13. So 3 times 9 is 27 minus 13, whoops, should give me 14. Okay. And then it says hence evaluate. So we broke this problem up basically into 2 pieces. This was the goal, and we found these values in order to find this, because this thing should be equal to the integral of h prime is just h, evaluated from 1 to 3. So then I'm going to take h of 3, and I'm going to subtract h of 1. So h of 3 is 14, subtracting h of 1, which is 15. So I should get negative 1 as my integral. Okay. And lastly, oh my goodness, it says evaluate the derivative of this thing when x is 1. So the first thing we want to do is we want to look at what the derivative would be. So if you have a coefficient in front of a function, you just leave the coefficient there. So it's going to be 2g prime of x. And if you're adding or subtracting, you just take the derivative of the next thing. So minus f prime of x. And we want that at x equals 1. So this is going to be 2g prime of 1 minus f prime of 1, which should give me 2. Go up to my table. G prime of 1 is 2. F prime of 1 is 1. 4 minus 1 is 3. Okay, so these are the notes for properties of integration. I hope they were helpful. I hope they make sense. I hope the practice makes sense. Post questions on the discussion board. I'll talk to y'all later. Bye.